Thank you. So I'm really excited to have the honor to be talking before Matitz, and it's like I'm his biggest fan on Twitter, especially of his profile pictures. I'm a huge Ruby fan. I used to do Ruby, let's be honest, probably before most of you. I used to do Ruby extensively until 5 years ago, and then maybe for 6 months, year and a half ago. But other than that, for the past 5 years, I've mostly been in the Node.js land and with some excursions to Java and other technologies. But this talk is about autoscaling on Amazon. And the implementation of our API was in Node.js, but as you will see, that's the least important bit, and you could probably easily do this with Ruby as well. I'm imagining Sinatra or something simple like that. I don't know is there something more cool than Sinatra nowadays in the Ruby world? What's the lightweight framework? It's still, yeah. I used to love Sinatra, and basically Express in Node.js, which is what we used, is it was inspired by Sinatra, so it should be familiar. So this is a little project that my friend Andre here and myself did last year. We were working for a startup called TV Beat. Maybe you heard about it, maybe not. And we had this engineering wet dream problem. So what TV Beat did is it collected data from pay TV platforms. So basically, when you're watching TV and switching channels, streaming server is recording what you're doing in some logs. And these logs were being pushed to us in real time. And they were being pushed to us via an API, HTTP-based API. So this story is about this API, basically how we scaled it, because as you can imagine, the amount of data is not like your average WordPress site. It's Andre actually knows the number, so we had, so we were peaking at 40K per second at some points. So because all our infrastructure was on Amazon, and we tried to use Amazon services as much as we could. We used Amazon Kinesis. Does anybody know about Kinesis? Shut up, Andre. So basically, Kinesis is you can imagine it. Does anybody know Apache Kafka? Kafka. Kinesis is managed Kafka. So basically, it's if I say basically one more time, just throw something at me. So it's a buffer between our ingestion and processing. You can imagine a distributed log or a queue-ish type of thing, which you put between your data ingestion and whatever you do to process that data. So in order not to choke your processing. So that's what we used Amazon Kinesis for, and it's actually quite nice. It's cheap and it's easy to use. The only problem is that Amazon Kinesis, like most Amazon services, has an HTTP-based API, and it's really tough to feed. So we needed actually a data ingestion API that can feed Amazon Kinesis in a sensible amount of time. And you can imagine we were trying to do real-time processing, so this amount of time had to be really short. So this is pretty much the API. When you hear the word microservices, pretty much this is what you have in mind. So the main endpoint was events, to which they were posting events. This is CoffeeScript, but it reminds me of Ruby, so it should be understandable. So this endpoint did two extremely simple things. Number one, validate the event, that make sure that they didn't send something extremely stupid. If you found some errors, just respond with 400 and those errors. If the payload was okay, then write to Kinesis. But write to Kinesis actually means in queue. So if you're not too familiar with event-based environments such as Node.js, pretty much everything you do is async. So write to Kinesis in this case is also async. It will enqueue an event rather than just finish writing. So the reason I'm mentioning that is, as you will see, it's really important because that queue can get really large. And once you do that, just immediately respond with 202 because we don't want our client to wait. Like, we don't want to put the burden of our processing onto them. So as you can imagine, one of these APIs is not enough because we needed uptime, among other things. And we used load balancing. And again, we used Amazon to do that. We used Elastic Load Balancer. So basically, we had EC2 micro instances. This was my idea. I'm like taking, so Andre told me I was crazy. But once we like evaluated our memory footprint, I said, fuck it, we can run this on a micro. And it's going to be such a cool story to tell. Like, you know, people are paying these huge bucks to run their services, but like micro is what, like $14. So basically, we had like n microservices and a load balancer in front of them. So when you do a load balancer, the first thing you need to do is create a health check endpoint. What every good load balancer and certainly Amazon load balancer does is it like pings your endpoint and basically asks the questions, are you alive? And this endpoint responds, yes, I am. So if it so happens that it doesn't respond with a 200 or it's just unavailable, what the load balancer will do, it will take it out of the load balancing group until it's back again. So load balancers have different algorithms, but usually it's like round robin. I think ELB is round robin. And basically you're out, and then once you respond alive again, you're back in, and you know. And as you will see, this health check endpoint will let us do some really nice things later on. So number one nice thing is that we started monitoring our queue sizes. So I mentioned that actually those events getting queued, and it's really useful to know how big these queues can get, because like if you don't care about this, you can fill up your memory, especially if you're on a micro. So this is like a really smart thing to monitor in these cases, and this is like the first thing we started with. So basically we have a really stupid piece of code that just goes like queue size plus plus, queue size minus minus, and monitors these queue sizes. And what this allows us to do is set a config option, which was like max queue size, which we magically calculated based on the memory footprint. And you know, once the queue size goes over this limit, we can take a break. You know, we can tell the load balancer, hey man, I'm full. Like don't serve dessert. You know, like, don't feed me anymore. So like 503. You know, I'm not alive. And when the queue size clears up, you know, this automatically becomes, okay, I'm alive again, and like you can feed me now. I think like the ping interval was something like 10 seconds. So, yeah, but it's configurable. So it's usually like a couple of seconds. You get to like clear your queue and come back. So that's the first nice thing we could do with this load balancer and health check. But, you know, of course it was not the end, because our use case looked like this. So TV daily curve. I'm sure you're all familiar with it, even maybe implicitly. But people don't watch TV like this, you know, all day. They watch TV in the morning and then like in the evening. So what happens is you get a daily curve like this, where the maximum point is sometimes, you know, 10 times the minimum point, or even more if it's World Cup. And we also have experience with a World Cup game. Opening game. Like most people enjoy the World Cup opening game, we didn't. And you have a use case for this. But what's nice is that like this is your school book auto-scaling use case. So this is like, I could do like, you know, I could take this maximum point and go like, okay, I need like 70 servers for this, and I just buy 70 servers. And then like most of the time, I'm like paying for, you know, 50 servers on average like an idiot, because I don't really need them. Auto-scaling lets you optimize your costs. So we went into that direction. So what we actually wanted to do is not have a fixed size auto-scaling group. but we actually wanted Amazon to add or remove instances as our throughput increases or decreases. So we created an auto-scaling group. And the first thing we had to do to pull this off is start sending our metrics to CloudWatch. So CloudWatch is like managed StatsD. Right? So it's like Amazon service, again, that like lets you monitor some metrics. And but as you will see, like based on these metrics, Amazon can also do things for you. So what we basically did, sorry, that's the last time I say basically, it's like years ago we had a drinking game on a meetup where like a colleague was giving a talk and he kept saying basically, and somebody tweeted like every time he says basically drink, and you could see like 40 people drinking all the time. So send to CloudWatch queue size. We started sending queue size to Amazon because based on that queue size, we could then create a scaling policy which said something really simple, which I'll explain right now. So you set a threshold, and threshold is obviously below our max queue size. So basically, before our instances start taking long breaks, we want Amazon to add more instances. So somewhere in between 0 and max queue size, we set a threshold at which point we want to add more instances. So basically, if average queue size goes over this threshold, you add n instances. In our case, n was 3. See, I'm old, Andre's young. He remembers the numbers. I remember the story. And if average queue size goes under this threshold, then you remove m. In our case, it was 1. I remember that. And there's a cooldown period in both cases, which was like several minutes. So like you don't start immediately because you can imagine imagine a situation when you have this threshold and like it just so happens that it goes like this every second. Like Amazon would be starting instances like crazy and killing instances like crazy. So there's a cooldown period. But this is basically how it works. And there's one thing you need to take care of when you have auto-scaling, and that's the fact that your instances just die like all the time, and you have to take that into account, that like they can get killed by AWS anytime. And as you can see, our solution was quite elegant. So basically, so once we get sick term, once our processes get sick term, we just set the max queue size to 0, and that pulls the instance out of the load balancing group and gives it enough time to clear its queue, and then it's dead. So dying a graceful death, and that's pretty much the only consideration you need to have when you want to go from a fixed size of your group to auto-scaling, which was a surprise for me because I can assure you that I'm an average intelligent person, so I thought auto-scaling was nuclear science. But the reason why I like talking about this is because we figured out it's not. It's actually quite simple to do. You do have to add a few things to your API, but you could really utilize AWS and save a lot of money actually. And that's the result. So the result was that we had an auto-scaling group that had anywhere between 7 and 70 instances. So in the morning it could have like 15, during the night 7, and in peak time, if there's a game on, like it could have up to 70. So it worked like that. We were able to feed Kinesis event by event in near real time. So many, when I spoke to Amazon support people, they said that many clients who use Amazon Kinesis actually have to batch events before putting them on Kinesis. So this is what we actually ended up doing in the beginning, but we hated it because we really wanted an elegant solution where we have like event by event on Kinesis, and then our consumers on the other side can just read from each shard event by event. And we were able to pull this off with this auto-scaling group in almost real time. And we did it at about like 1/3 of the cost, compared to doing it without auto-scaling. And Andre was even mentioning things like spot instances that would decrease the price even further. But this goes to show that, if you're talking about like a few dollars, then maybe you don't even want to bother. But once you start talking about, thousands, then just investing a little bit of time in autoscaling. I think our first prototype was like done in a day or less, because we drank beer and could focus. It really, pays to think about it, because you can really save a bunch. And yeah, thanks. So I had these slides in London, and Andre wasn't there, so this is why I'm thanking him. Now, like, I forgot to remove this slide. Thank you, Andre. And thank you for listening. That's.
So the Kinesis doesn't care how many events you fit to it?
Oh, it does, because it charges you for it.
But like the sheer volume, because once you have 70 instances, you will spend more than we have.
So basically, that's okay. The talk is done now. I can say basically. So you pay for a shard. So one shard is, if I remember correctly, you can write 2K. You can write 1K and read 2K per second. 1 megabyte and read 2 megabytes per second. And the cost for one shard is something like $70 per month. So something ridiculous like that. Of course, it's not only throughput that you want to consider, but also how you want to distribute your processing. So sometimes you need more shards, even though you don't have the 1 megabyte per second throughput. But what you pay for is this. And 1 megabyte, unless your events are really huge, 1 megabyte is a lot per second. So we actually did hit that limit at some point. Yes, we had 6 shards, but the main reason why we had 6 shards eventually was not the sheer throughput, but the fact that we had like 6 plus consumers on the other end. And we wanted to shard data in a different way, like partition the data, not because we had like 6 megabytes per second on average. But yeah, so it does care, it does measure the throughput, and you have to pay for that, of course. But in most cases, it's ridiculously cheap and not an issue. The biggest issue is the latency between the thing that fills Kinesis and Kinesis itself. So we were able to pull off like 60 milliseconds per one event, because we were in the same availability zone as Kinesis. But for example, if this API was in the States and Kinesis in Europe, or vice versa, or whatever, like it would be much more than 60 seconds. And this, like if it's, for example, 200 seconds, that means that our autoscaling group would need to have not 70, but like 250 servers. So these things are really, like, because of a few milliseconds, you end up paying like 3 times more. But in a general case, yeah, like it does care about the throughput, but usually it's not a problem, and it's cheap. Sure. How do we deploy? Oh, it's Andre. Yeah, so, well, we had like the best deployment procedure in the world. Like maybe Andre can explain, actually.
I mean, it's kind of like you have a lot of businesses that probably deploy some new code.
Yes, not basically, but you have your image, and when Amazon scales you, like you don't really deploy, like Amazon just clones your image. So we had Andre, who were managing the ops here, the best ops engineer in the world, and he created these images. So we had an image for this type of service, and what we had on this image is actually quite simple. So we had like Linux and Node, and the dependencies that we needed. But yeah. So it's not like you don't have it. It can like seem like a lot of work, but it's actually not. It's not you who's doing the deployment to all these instances. Like Amazon does it for you automatically.
Update the image, Amazon updates.
Yes. Yeah. Yeah. So it's, yeah, like, the answer is actually yes. Yeah, but
another question, can you consider elastic instant because it has autoscale groups really easy to set up?
to be honest, I read about Beanstalk sometime in the past, but no, like I heard about it.
You just control.
Exactly, like it's kind of like this was just like one step away from what we already had, and Beanstalk seemed like 16 steps away. And maybe like after this we would have gone into that direction, but
Yeah, because I use it in Beanstalk and it works quite nice, especially in autoscaling, and you can set up rules for different This is a rule and this is my image that you have to deploy, and if you deploy it, it's automatically approved for instances. So the many problems that you can think of.
I think that what we did is so simple that we didn't actually incur a lot of pain. And, had it been slightly more complex, or, to be honest, like if I was still at TV Beat, maybe like at this point I would be doing Beanstalk, because we would mature that autoscaling solution to the point where we want something more. But to be honest, I hadn't had any experience with autoscaling when I did that. So it was kind of like our first project. I didn't really want to, take all these steps further. Just yeah. Oh, this is if like I had 2 beers, so I can give you an honest answer, because I thought it was cool. But well, as I said, so we took a look at our memory footprint. We had an insanely simple service that does something really stupid, like just a quick validation and then puts that onto a queue. And we decided to use microservices instead of micro instances instead of bigger instances with larger queues. To be honest, we did use, like for some special cases, we did have some larger instances, and they had larger queues because we had some special cases where pay TV platforms would be sending us batches, not like single events, but huge batches of like tens of thousands of events at once. And this was not the use case for this. So we actually ended up using bigger instances, but only for these special cases. But micro instances work really well. It's not just cool. It's also like, it gives you a really nice feeling of, granularity and control, and cost control. Exactly. Yeah. Because you can imagine if a thing costs $14, it's much easier to say give me like 10 more or 3 more. But if a thing costs like $354, like you don't have a choice in between. You just have to go like, well, let's spend another $350 per month because maybe our usage went up 20%. So with microservices, you get this cost granularity, and micro instances. But I do realize that it wouldn't work in every case. In most cases actually, because the memory is so limited. So in this case, we were just lucky, I guess. We had the use case for it.
Another question. We also experiment with autoscaling groups
so we didn't use Beanstalk.
ELB.
Yeah, well, ELB, we used ELB even before going the autoscaling route. Gesundheit. So yes, of course, like ELB we used it for other things as well. But autoscaling group was actually eventually it was the solution. So
could you do this without these microinstances and go to the autoscaling groups, or?
So we could. Well, autoscaling group, like these micro instances were in an autoscaling group. and they were managed by an auto-scaling policy. We could, you know, there are obviously like other ways we could have done it, and we could have had, you know, bigger boxes with more app instances on them and more memory and bigger queues. But, you know, as I said, like we liked the idea with micro instances because it was, you know, easy to control the cost. We could fit the problem into one micro instance. So yeah, but you know, to answer your question, yes, eventually this was all managed by an auto-scaling policy in an auto-scaling group. Yeah. Yes. Does anybody? Now I was about to ask. Does anybody want to ask me? Is CoffeeScript better than Ruby? Yeah. Okay, you can.